This is a demonstration of the Coltraco Portasonic PRO. The Portasonic PRO is supplied with a handheld tablet pre-installed with the software and the central processing unit. Also included are a USB-C to USB adapter to connect the processing unit directly to the tablet, a pair of DM10 sensors, a pair of chain clamps to secure the sensors to the pipe, and some ultrasonic grease. Here I've got a 40 millimeter diameter PVC pipe with water flowing through it. I'm going to demonstrate how Portasonic PRO will measure the flow rate in this pipe. To begin, connect the USB-C with the A adapter to the central processing unit, then connect it to the tablet. Once it's connected to the tablet, you'll see the device info appear along with some other information. Be sure the light is green and then click Install. In the Install section, choose your pipe material type. I've chosen PVC. Enter the outer diameter, the wall thickness, and the number of passes. Input your fluid type, in this case it's water, put in the fluid temperature, and it will give you a recommended transducer spacing here. The spacing given is 30.3 millimeters. Now apply some silicone grease to the surface of your ultrasonic flow sensor. You don't need much, just a thin smear. Ensure the upstream and downstream are pointing correctly, and install the sensors on your pipe, securing them with the chain clamps. To fasten the chain clamps, just pull them across the sensor and the pipe as shown here. Ensure the sensors are securely fastened and then measure the distance between the sensors. Reference the transducer spacing, which is 30.3 millimeters. I'm measuring this now, and it is 30.3 millimeters. Once you have the right spacing, press Measure. You'll then see a waveform, and it will slowly adjust to account for the gain that is required in your setup. Now scroll all the way down to see the ATA-ETA. The ATA-ETA needs to be within 3% of 100%. That's the error allowable, plus or minus 3% from 100%. To improve percent of the signal, you could adjust the sensor position a little bit. Here, I pushed one sensor closer, and you can see the ATA-ETA improve after that's been done. It's now gone to 98%. Give it a few seconds for it to stabilize. Once you're happy with the ATA-ETA and the shape of the waveform, you can scroll up to view your measurement. The flow velocity will update in a few seconds to the actual flow velocity. This will also be reflected in the volumetric flow rate as well as the mass flow rate. It will take a few seconds for the flow velocity and the flow rate to climb to the actual value. This accounts for any fluctuations as the flow meter builds up to measuring the actual flow rate. Once it has achieved a stable flow, you'll see that it will maintain that flow rate.